Okay, let's unpack this a bit. We all have ideas, right?
Yeah.
Those flashes of inspiration, those, brilliant mental blueprints for something totally new. But how often do those amazing thoughts just, well, stay thoughts?
Yeah, that's the key question.
How do we actually take an abstract idea and make it, well, tangible, give it impact? How
Yeah.
do we bridge that gap between just thinking and actually doing?
It's a huge challenge.
So today, we're diving deep into this really interesting framework for innovation. It's called the innovative phase, and it comes from the Taxshila Technology Development Model.
Right.
Our mission here, really, is to explore that critical point where thought meets action, where those mental blueprints suddenly leap into physical working reality.
Exact.
It's about understanding the real power of bringing ideas to life, not just having them.
And what's truly fascinating here, I think, is that this isn't just some abstract project management idea.
No.
No, the innovative phase is actually a deeply neurological and physical process.
Yeah.
It activates very specific parts of your brain.
We're going to explore how some surprising things like your motor skills,
Yeah.
your actual ability to do things with your hands, your body,
Mm-hmm.
and even embracing what looks like failure play this crucial role in genuinely turning thoughts into real-world innovation. It's more than just knowing stuff. It's applying it.
Right. Applied knowledge. So let's define this innovative phase clearly for you listening. It's the fourth stage in this Taxshila
The
model.
fourth, yes.
And it acts as this crucial bridge connecting all that foundational learning you did earlier, the definition, structure, cognitive phases, with actual real-world application.
That connection is vital.
Its core purpose, creativity in action. This is where all that internalized knowledge, that conceptual stuff, what the model calls brain page knowledge,
Brain page.
that's where it becomes functional designs, actual prototypes.
Hmm.
It's where the abstract blueprint meets the messy reality of the physical world.
Exactly. And this phase is really rooted in motor science and knowledge transfer theory.
Motor science. Yeah, it's anything but passive. It absolutely demands active engagement with tools, with materials, systems, the whole environment around you.
So you have to get your hands dirty.
You absolutely do. Think
Yeah.
about learning to ride a bike, right? You can read books about balance and physics all day long. But until you actually get on the bike and try, and probably fall a few times, your understanding is just incomplete.
Right.
So this phase needs precision, it needs adaptability, resilience too, because success often hinges on how well you respond to feedback in real time, how you handle those inevitable failures, and how committed you are to tweaking things again and again. Iterative refinement.
Okay, and this is where I think what's happening inside our heads gets really interesting. Let's talk about the neurology here.
Yeah, the brain science is key.
So the phase before this, the cognitive phase, that primarily activates the cognitive circuits of your brain.
Right.
The thinking parts. Exactly. All that intellectual heavy lifting, acquiring knowledge, understanding complex stuff, solving problems in your head. We're talking about higher order thinking, memory centers, processing information. It's the thinking part, basically.
But then, in stark contrast, the innovative phase shifts that focus quite dramatically.
How so?
Well, this stage is really characterized by the intense activation of the developer's motor circuit.
Those are skits, okay?
Yeah, the parts of your brain involved in movement, coordination, learning physical skills, integrating what you see with what you do.
Oh, well,
This is where visuomotor learnography, a bit of a mouthful, but basically learning by seeing and doing with your hands really comes into play.
so it's the hands-on work.
It's the hands-on work, the prototyping, the testing, the refining. That's what engages these motor circuits and integrates the information deeply. It really highlights how dynamic tech development is, These cognitive and motor phases aren't separate. They're complementary, both absolutely essential.
So if that's the what and the where in the brain,
Yeah.
let's focus on the how. How does innovation actually happen in this phase?
Yeah.
It sounds like it's all about trial and error, right? Experimentation.
Very much so. Task-oriented experimentation.
And we often think of motor skills as just, how we execute things. But you're saying they're more than that. They're vital for the experimentation itself.
Absolutely vital. Almost a prerequisite for effective technological experimentation.
What makes them so crucial?
It's because that hands-on engagement, the physical action, it's incredibly powerful for learning. It actually leads to stronger memory encoding.
Stronger memories.
Yes, and much deeper conceptual clarity than just thinking about it. This Motor-driven experimentation, it actively strengthens the neural pathways involved. It makes the learning stick, makes it more robust, more
Can you give an example?
Sure, like you can read a lot about how a complex watch mechanism works, right?
Mm-hmm.
Understand all the gears and springs intellectually,
Mm-hmm.
but until you've actually taken one apart, maybe struggled to put it back together, maybe even tried to fix a tiny broken part with your own hands, your understanding is still largely abstract.
Right, it's different.
That physical interaction solidifies the knowledge in a way reading or just thinking alone simply cannot.
In this physical struggle, this hands-on part, that brings us to something really interesting you mentioned earlier, this concept of dark knowledge.
Ah, yes, dark knowledge. It sounds mysterious, but it's quite practical.
What exactly is it? You said it can't be taught directly.
That's right. It's about those hidden patterns, those intuitive insights, maybe novel approaches that you kind of stumble upon. They're discovered through immersive, hands-on exploration, and yes, often through that struggle, that trial and error.
So it's like that aha moment.
Exactly, that sudden insight that comes when you're deeply engaged in the doing, maybe feeling a bit stuck, and then a solution just clicks, seemingly out of nowhere. It arises from the action itself.
And speaking of struggle, you also mentioned failure. How does that fit in? Usually we try to avoid failure.
Well, in this phase, failure gets reframed. It's transformed from just a setback into a really powerful learning mechanism.
How does that work?
Through those iterative cycles, you build a prototype, you test it, it likely fails in some way, you figure out why, and you refine it.
Okay.
Failure is basically essential feedback. Each failed attempt gives you crucial data. It tells you what doesn't work, and sometimes, importantly, why it doesn't work.
So it clears the path.
Precisely. It creates a clearer, more refined path towards an effective design and ultimately successful innovation. It's not about avoiding mistakes at all costs, but about learning from every single one, treating them as data points.
Okay, so if we're activating motor circuits, discovering this dark knowledge, embracing failure, how do we guide this? How do we make it structured, not just random tinkering?
That's a great question, and that's where the essential knowledge transfer dimensions, or KT dimensions, from the Taxshila model come in.
KT dimensions.
Yeah, they provide a kind of framework, some guiding principles to help navigate the complexity of this innovative phase.
What are they?
Well, they're crucial for structuring the process, helping you move from the abstract idea to concrete action. So first, you have the task formator.
Task formator.
Right. It helps you structure your goals, figure out the sequence of steps, set priorities within the actual experimental process. It's about breaking down the big idea into manageable, actionable chunks.
Makes sense.
Then there's the module builder. This helps you integrate all the different pieces of knowledge, the different components or fragments, into a working prototype. It's how you bring disparate parts together into a functional whole.
Okay, got it.
And finally, one of the key dimensions is dark knowledge itself, recognizing its role.
Right, the discovery part.
Exactly. Acknowledging that part of the process involves subconscious problem solving, those creative leaps that, as we said, are discovered uniquely through doing, not through being told.
So it's this combination, then the task formator, module builder, and acknowledging dark knowledge that really guides the whole design and experimentation.
Yes, precisely. It connects the thinking with the actual behavior, the imagination with the execution. It's like the blueprint for making things happen effectively, ensuring your efforts are directed and productive, not just flailing around.
Okay. And how does this connect to, the real world beyond just building a prototype?
Ah, well, that's critical. When we connect the innovative phase to real-world impact, it becomes clear that innovations must be practical. They need to be relevant, applicable.
Not just cool tech for its own sake.
Exactly. You have to consider market demand. You need to focus on the user experience. You have to understand the potential for widespread adoption. This whole approach ensures that innovation is aligned with actual societal needs and produces solutions that matter, not just clever ideas that sit on a shelf.
And there's always risk involved, isn't there?
Oh, absolutely. Innovation inherently involves a significant element of risk. Call it risk and reward.
Right.
It demands courage, courage to challenge how things are done, to put your ideas out there knowing they might fail, and a willingness to accept those potential failures. But the flip side is that the rewards can be absolutely monumental, reshaping entire industries, profoundly improving people's lives. That potential payoff often justifies the risk.
That makes sense.
And crucially, going through this phase really fosters an entrepreneurial spirit, A maker mindset.
A maker mindset.
Yeah. Learners or developers, they become not just problem solvers in theory, but actual creators, inventors, system builders. It cultivates autonomy, real self-direction.
And presumably makes them more ready for the real world.
Exactly. It prepares individuals with a kind of real-world readiness that goes far beyond typical academic learning. It gives them the confidence and the practical skills to actually execute their ideas.
The implications here seem pretty huge then, much bigger than just one person's project.
Oh, definitely. This model, this way of thinking, it really encourages a fundamental shift. Think about education moving from passive learning towards experiential innovation.
Like maker spaces.
Precisely. Maker labs, brain page classrooms, where hands-on application is absolutely central. It also informs industry practices, suggesting companies use real-world problem sets for R&D, not just simulations, get people tackling actual challenges, and it can even guide policymakers, helping them understand how to support innovation ecosystems that truly prioritize doing, making, and that crucial link between thinking and acting.
Wow, okay.
Eh?
So let's try and summarize this deep dive then.
Sure. I think the core message is that the innovative phase really redefines what innovation is. It's not just that sudden flash of insight.
Right.
It's a disciplined motor cognitive process. It's rooted in that hands-on experimentation, in embracing failure as valuable feedback, and in structured, guided problem solving. It's really about the synergy, the powerful connection between the mind and physical movement.
Yeah.
That journey from knowing to creating.
Yeah, and what really struck me today is how those motor skills aren't just tools for execution. They're actually neurological activators.
Exactly.
Activating procedural memory, your how-to memory, and embodied cognition. The idea that our physical experience shapes our understanding. And that's what lets you genuinely turn ideas into meaningful change, into real impact.
Which I think raises a really important question for you listening.
Oh.
How can you activate your innovative phase? You know, whether you're a student working on a project, an engineer designing something new, or frankly, just someone trying to solve a problem in your everyday life. Consider how that hands-on engagement, how embracing failure not as an end but as feedback, and how allowing for the discovery of that dark knowledge through struggle, how all that can transform your own journey, moving from just knowing something to actually creating something with it.
That's a great challenge. So go on, ignite your motor circuits, build your brain page.
And let your creations speak.